In this video, we'll learn the concepts of random variable and probability distribution. We'll look at the probability histograms and how to read them. We'll also learn about finding the important parameters of mean, standard deviation, and variance for probability distribution. But most importantly, we'll be able to determine whether the outcomes are significant, significantly high, or significantly low. Let's begin by relating the concepts of random variable and probability distribution.
First, let's learn some vocabulary words of probability distribution. A random variable is a variable typically represented by x that has a single numerical value determined by chance for each outcome of a procedure. In this chapter, we'll focus on discrete random variable, which is a collection of values that is countable. In the next chapters, we will look at continuous random variable that has infinitely many values and the collection of values is not countable. A probability distribution describes the distribution of values of the random variable using probabilities instead of frequency counts. Every probability distribution must satisfy each of the following three requirements. First, random variable x has a numerical value, not categorical, and its number values are associated with corresponding probabilities. The sum of probabilities must be equal to 1, but sums such as 0.998 or 1.001 that results from rounding errors are also acceptable. The sum of 1 represents all single events in the entire sample space. And the last requirement, each probability value must be between 0 and 1. Let's practice recognizing the requirements of probability distribution. Ted is not particularly creative. He uses the pickup line. If I could rearrange the alphabet, I'd put you and I together. The random variable x is the number of women Ted approaches before encountering one who reacts positively. Do you think this distribution table represents the probability distribution? Let's check the requirements. The first requirement is the random variable must be a numerical value, which in this case, it is a numerical value. Second requirement, the sum of probabilities must be equal 1 or close to 1. Let's add the probabilities. They add up to 0.100. Looks like this table does not meet the requirements of probability distribution, and Ted needs to choose the other pickup line. Obviously, this one is not working well. Another example. In a Microsoft Instant Messaging survey, respondents were asked to choose the most fun way to flirt in the company table based on the results. Email, 0.06 probability. In person, 0.55, instant message, 0.24, text message, 0.15. Do you think this table represents probability distribution? No, because the first requirement is not met. Random variable is not numerical variable, it's categorical variable. Another example, the following table describes the numbers of adults in groups of 5 who reported sleepwalking. Let's check if this table meets the requirements of probability distribution. Random variable x is a numerical value. Yes. It represents the number of adults who reported sleepwalking. Requirement 2. The sum of probabilities must be equal to 1 or close to 1. The sum of probabilities adds up to 0.999, which is very close to 1. This result might be from the rounding error. And last requirement, that each probability is between 0 and 1. Yes, this requirement is also met. So this table meets the requirements of probability distribution. Let's look at the histogram that represents this table. In StatCrunch, I was only able to build the bar graph. Remember, histogram is a bar graph with no gaps between the bars. It's called a probability histogram because the vertical scale shows probabilities instead of relative frequencies. Now let's look at some formulas that will help us to find the parameters of a probability distribution. Why I say the parameters and not statistics? Because with the probability distribution, we have a description of a population instead of a sample. So the values of the mean, standard deviation, and variance are parameters and not statistics. Mean for probability distribution is found by adding all the products of the random variable times its probability. Variance is found by the formula sigma squared equals the sum of the square of the differences between each value of random variable and the mean times each probability. This format is easier to understand, and this format is easier for manual calculations. We'll do one example where we would calculate the mean, variance, and standard deviation manually, and then I'll show you how to do it on StatCrunch and Graphing Calculator. Standard deviation for probability distribution, sigma, is found by taking the square root of the variance. If you use StatCrunch or Graphing Calculator, you will not have to use these formulas at all. And the last vocabulary word. The expected value of a discrete random variable x is denoted by e, and it's the mean value of the outcomes. So e is equal to mu, mean. And e can also be found by evaluating the sum of the product of each random variable and its probability. Let's consider tossing two coins with the following random variable, x, that represents number of tails when two coins are tossed. When we toss one coin, we can get heads or tails. When we toss another coin, we can get head or tail. So we have 4 possible outcomes: head, 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 tail, tail, head, and tail, tail. This is our sample space that represents all possible outcomes. We would expect tail 1 out of 2. It's either tail or head, right? Let's build the probability distribution table. Out of 4 possible outcomes, tails come up 0 times, 1 out of 4. There's one time when we have head, and no tails. One tail comes up 2 out of 4 times, or 0.5. One tail, 2 times, head, tail, and 2 tails come up 1 out of the 4 outcomes. 1/4 equals 0.25 as a decimal. Let's find the mean and the standard deviation. I'm going to use the following formula to find mean. Mu is equal to the sum of the product of each value of the random variable multiplied by its probability. So I'm going to build extra column that would represent the product of the value of the random variable times its probability. 0 times 0.25 is 0. 1 times 0.5 is 0.5. 2 times 0.25 is 0.5. Then we need to find the total. That's what this sign means. The sum, which is equal to 0.5 plus 0.5, 1. So mean of this probability distribution is equal to 1.0. Now let's find standard deviation. And I'm going to use the formula that is easy for manual calculations. Standard deviation is equal to the square root of the variance. The sum of square of a difference between the value of the random variable and the mean times each probability. Let's add another column. First, we need to find each difference between the value of the random variable and the mean. So we would call this column x minus mu. Then we'll need to square each value, x minus mu squared. And then we would multiply x minus mu squared times p of x. And then find the total. Let's start with the first column. 0 minus 1 is equal negative 1 squared equals 1 times probability distribution 0.25 is equal 0.25. 1 minus 1 is equal to 0 squared equals to 0 times 0.5 equals 0. 2 minus mean 1 is equal 1. 1 squared equals 1. 1 times 0.25 is 0.25. Now let's find the total. 0.25 plus 0.25 is equal to 0.5. This is our value right here under the square root. This is the variance basically. Sigma squared. Variance is equal 0.5. Now a square root of a variance will give us standard deviation. Square root of 0.5 is 0.70707 and so on, approximately rounded to one more decimal than the original values, just like the mean. The original values of a random variable are the whole numbers, so we round the mean and the standard deviation to one more decimal. So standard deviation is equal 0.7 and the mean is equal 1. Now remember these two values, because now we will look at how to use the mean and standard deviation to identify significant values, significant high or significant low values. X number of successes among n trials is a significantly high or significantly low number of successes if the probability of X or more successes is 0.05 or 5% or less. That is, X is a significantly high number of successes if P of X or more is less or equal 0.05, or X is a significantly low number of successes if P of X or fewer is less than 0.05. The value of 0.05 is not absolute. Other values such as 0.01 or 0.02 or 0.1 could be used to distinguish between results that are significant and those that are not significant. Significant high values are considered the values that are 2 or more standard deviations from the mean, and significant low values are considered the values that are 2 or less standard deviations from the mean. In our example with 2 coins tosses, the mean was equal 1.0 and standard deviation 0.7. Let's find significant values. Significant high values will be 2 standard deviations from the mean. So it will be mean plus 2 times standard deviation. Mean is equal to 1 plus 2 times 0.7, 1 plus 1.4, 2.4. So any value that is higher than 2.4 will be considered significant high. Now let's find significant low values. Mean minus 2 times standard deviation. 1.0 minus 2 times 0.7. 1 minus 1.4 is equal negative 0.4. Therefore, any value that is lower than negative 0.4 will be considered significant low value. Since we are talking about coin tosses, there is no value that is less than negative 0.4 because the coin toss cannot be negative value. And because there is only 2 sides, head and tail, there is not going to be a value that is greater than 2.4. But the point of this example is to show you how to find the values that are significant high and significant low. And finally, let's look at the probability histogram for the 2 coins toss example. Remember, our values for random variable were 0, 1, 2, and the probabilities for those values 0.25, 0.5, and 0.25 for 2 tails. The probability histogram resembles a relative frequency histogram, with the exception that in probability histogram, the vertical scale shows probability instead of relative frequencies. The number of heads or tails, 0, 1, 2, the probability of 0.25, the probability of getting 1 head or 1 tail, in this case was 1, the probability of getting 2 heads or 2 tails, 0.25. we can see the shape of the distribution from the probability histogram. Now we will look how to find the mean and standard deviation using the StatCrunch. In the StatCrunch, I'm going to enter values for random variable in the column var1, and I'm gonna rename it to column X, and I'm going to rename column var2 to P of X. Our X values were 0, 1, and 2. P of X values, probability of getting 0 tails when 2 coins are tossed is 0.25. Probability of getting 1 tail, 0.5. And probability of getting 2 tails is 0.25. Now to find mean and standard deviation, go to Stat, Calculators, down to Custom. In the values, select column X. In the weights, select P of X. Click Compute. The mean is 1, standard deviation 0.7, and we can see the shape of the distribution as well. The probability of getting 0 tails when 2 coins are tossed is 0.25. Probability of getting 1 tail is 0.5. Probability of getting 2 tails is 0.2. We will review later what this part means when we learn about binomial distribution in the next video. We will now look at how to find mean and standard deviation from probability distribution using TI Graphing Calculator. Go to Stat, Edit. In L1, enter the values of random variable 0, 1, 2. In List 2, L2, enter the probabilities 0.25, 0.5, 0.25. If you have other values in either of the lists and you need to clean the list, just go up to the list name, click Clear, and enter. Now you can enter the values that you need. 0.25, 0.5, 0.25. Now go to Stat again, to Calculators, click 1 or 1 var stats, enter. In List, you should have L1. In Frequency List, put L2 if you don't have anything here. Then go to Second, 2. On the top, you will see L2 is marked in blue. That's what second means. Click 2, enter, enter again, and you will see mean as X bar. Standard deviation, sigma of X, is 0.707. So now you can calculate the mean and standard deviation from probability distribution using either StatCrunch or TI Graphing Calculator. Coming up next, Chapter 5.2, Binomial Probability Distribution. Stay tuned.